We want to look at what do we mean by average propensity to consume and how do we find it, first mathematically and then graphically. Now, average propensity to consume is the proportion of total disposable income that is spent on consumption. So when you want to find it mathematically, we just take the ratio of total consumption to total disposable income. So it will be calculated as APC is equal to C divided by YD, where if you take our consumption function to be C is equal to C naught plus C1 YD, so this becomes C naught plus C1 YD divided by YD. And then you can simplify this as C naught by YD plus C1. Now, the first thing to note over here is when we talk about MPC, we know marginal propensity to consume is constant. But we can see over here, APC is not a constant because as we increase disposable income over here, we can see APC is going to go down, right? YT is in the denominator. When the denominator increases, the fraction becomes smaller. So as disposable income increases, this part remains constant, but this part goes down, so APC goes down. So let's look at how do we graphically find APC. Now we know a standard consumption function graph on the vertical axis will take consumption, on the horizontal axis will take disposable income. Now we can calculate, now we know MPC is constant, right? It's the slope of this consumption function. But when we want to calculate APC, we know APC is not constant. APC goes down as disposable income increases, right? Because it's not constant, we can calculate the APC at any point on this consumption function curve as the slope of the straight line connecting that point on the consumption curve to the origin. So say I want to calculate APC at point P. What we will do is we will calculate it as the slope of the straight line connecting that point to the origin. So we're going to draw a line from the origin to the point P like this line OP. And the slope of this line OP is going to equal the average propensity to consume, because see what its slope is going to be. Its slope is going to be the consumption at this point C1 divided by disposable income at this point by D1, and this is what average propensity to consume is, the ratio total consumption to total disposable income. So mathematically you want to find average propensity to consume, just take the ratio. Graphically, at any point you want to find the average propensity to consume, just draw a straight line from the origin to that point. The slope of that line, the slope of the line connecting the point on the consumption function to the origin gives us average propensity to consume, because its slope is essentially the ratio of consumption to disposable income at that point. Now, something to note over here is we mathematically saw that as disposable income increases, as YD increases, APC goes down. We can show this graphically as well over here, where we can see the figure here shows that the line from the origin becomes flatter at higher income levels. We can see the line that connects the origin to A is steeper than the line that connects the origin to B, which is steeper than the line that connects the origin to point C, right? So as disposable income increases, we can see average propensity to consume goes down, because we know the average propensity to consume is represented by the average propensity to consume at any of these points is represented by the slope of the line at that is represented by the slope of the line connecting that point to the origin. For example, at A, the average propensity to consume is the slope of the line OA. At B, the average propensity to consume is the slope of the line OB. At C, the average propensity to consume is the slope of the line OC. And we can see as disposable income increases, the slope of the line becomes flatter and flatter, so the APC goes down. So we're shown this graphically as well. Average propensity to consume is not constant, it goes down as disposable income increases.